is equal to the sine of x over the cosine of x. Now we know that the tangent is equal to y over x. And we know that the sine is equal to y over r, and the cosine is x over r. So if I take a look at the right-hand side, and I take y over r times the reciprocal of the denominator, which is r over x, and divide out like factors, that's where I get y over x equals y over x, and that's why the tangent is equal to the sine over the cosine. So that's one that you should remember, because we're going to need that. You're going to need to use that. So I'm verifying where it came from for you here. There. So again, I could verify this. I know that the cosine is x over y, and I know that the cotangent is x over y. The cosine is x over r, sine is y over r. So when I look at the right-hand side, I can take the numerator times the reciprocal of the denominator, divide out like factors, and that's why the cotangent is equal to the cosine. Cotangent x is equal to the cosine of x over the sine of x. So that just verifies that identity. We've done reciprocals before, but if you have the cosecant of x, that's equal to 1 over the sine of x. And of course, in the same way, the sine of x is 1 over cosecant. Secant of x is equal to 1 over the cosine, and cotangent is equal to 1 over the tangent. And of course, we can go the other way, but typically what we want to do many times in verifying these identities is to get everything in terms of the sine and cosine. So that's why I'm writing the reciprocal identities this way, because typically we're going from cosecant to sine, or from secant to cosine, or cotangent to tangent, because those on the right are the ones that we use most often. The one we use most often as a Pythagorean identity is that sine squared x plus cosine squared x equals 1. And this is going to come up quite a bit in the work that we're going to be doing, some today, but more on Monday. Another one that we have is 1 plus tangent squared x is equal to secant squared x. So if you see secant squared x, you can replace it with the substitution of 1 plus tangent squared x. And 1 plus cotangent squared x is equal to cosecant squared x. Okay, so this is a typical problem. You're given the cosine. Well, cosine being negative means you're either in the second or the third quadrant. However, you're then told that theta lies between pi and 3 pi over 2, which means that we are in the third quadrant. They're telling you you're in the third quadrant. We always drop a perpendicular to the x-axis. And then the cosine being x over r, we have the x value is -5, the radius is 13, and we can use the Pythagorean theorem. -5 squared plus y squared equals 13 squared. 25 plus y squared equals 169. Y squared equals 144. Y is equal to 12. However, you're in the third quadrant where y is negative. So that's why it's always a good idea to make a diagram. Put it in the proper quadrant. And then you have the x, y, and r properly labeled, so that now when we have tangent, which is y over x, and the y value is -12, and the x value is negative 5, then we get an answer of positive 12 over 5, which we know is correctly labeled positive or negative because we know that tangent is positive in the third quadrant. And then sine is equal to y over r. So the y value is 5, the y value is 4, the radius is 5. And then you're finding the x value. X squared plus y squared equals r squared. X squared plus 16 equals 25. X squared is equal to 9. X is equal to 3. This is a common right triangle, a 3, 4, 5 right triangle. However, the x value in the second quadrant is negative. And then again, that's why it's a good idea to make a diagram, because then if you're finding cotangent, which is x over y, the x value is negative 3, the y value is 4, and we're getting a negative 3/4, which is consistent with the fact that we know cotangent is negative in the second quadrant. Okay, in this problem, you're given the cotangent is 3/4, which means you could be in the first or the third quadrant. However, it tells you that x is between pi and 3 pi over 2, which places it in the third quadrant. Now, cotangent is equal to x over y, so the x value is 3 and the y value is 4. However, again, by making the diagram, they're not positive 3 and positive 4. They're negative 3 and negative 4 because x and y are negative in the third quadrant. And then again, this is a 3, 4, 5 right triangle. I don't think I need to do the Pythagorean theorem with you again. And the sine is equal to y over r. The cosine is x over r. Tangent is reciprocal of cotangent, 4 over 3, or negative 4 over negative 3 simplified. The cosecant, now even though I know that the r value is not the one that's negative, I usually put the negative in the numerator, either in front of the fraction or in the numerator, but we very seldom leave it as 5 over negative 4. We usually write it as negative 5/4 with it out in front, or negative 5 in the numerator over 4. And secant, so we have the square root of 5 over negative 2, and typically again, we put the negative in the numerator, even though I know that it is not r that's being negative, and the cotangent is reciprocal of tangent, which is negative 2.